Assalamualaikum warahmatullahi wabarakatuh. Today we are from Group 8 consisting of 6 members. Nur Umairah binti Kamaruddin, Nur Izzah binti Muhammad Shukri, Nur Adriana binti Ruzu Azura, Nur Azrah binti Budiman Razi, Aminatul Izzah binti Muhammad Nasri, and Ilham Husna binti Azmi. In our poster project, we need to elaborate on the contribution of Muslim scholar at addressing current issues through Islamic science. So, our group chose Al-Khawarizmi as our Muslim scholar. This is our poster of Al-Khawarizmi, and we include some important details in the poster, such as backgrounds, life history, and contribution that we can practice and learn in our life. Next, I will describe a little about the background of Al-Khawarizmi. His name is Abu Abdullah Muhammad ibn Musa Al-Khawarizmi. His nickname is Al-Khawarizmi, called as a father of algebra. The birth date is on 780 in Khawarizmi. Date of death is 850 in Baghdad, Iraq, which is his age was 70 years old. In expertise, the fields of mathematics, astronomy, and geography of Iran. Family lineage, born into a Persian family, and Ibn al-Nadim gives his birthplace as Al-Khawarizmi in Central Asia. Additionally, this is about his life history. Al-Khawarizmi was an algebra teacher in Europe. He has invented the application of secants and tangents in trigonometric and astronomical research. At a young age, he worked under the Caliph al-Ma'mun, that is working at the Bait al-Hikmah in Baghdad. Next, I would like to show about the contribution of Al-Khawarizmi. There have a lot of contribution that Al-Khawarizmi have given to us until now, especially astronomy, geography, trigonometry, and algebra. Firstly, algebra. The compendious book on calculation by completion and balancing is a mathematical book written approximately 820. The book was written with the encouragement of Caliph al-Ma'mun as a popular work on calculation and is replete with examples and applications to a wide range of problems in trade, surveying, and legal inheritance. The term algebra is derived from the name of one of the basic operations with equations, al-jabar, meaning restoration, referring to adding a number to both sides of the equation to consolidate or cancel terms, described in this book. Al-Khawarizmi method of solving linear and quadratic equations work by first reducing the equation to one of 6 standard forms, where b and c are positive integers. For example, squares equal roots, square equal number, roots equal number. Secondly, astronomy. Al-Khawarizmi Zij al-Sinhin Astronomical Tables of Sindanta is a work consisting of approximately 37 chapters on calendrical and astronomical calculations and 116 tables with calendrical, astronomical, and astrological data, as well as a table of sin values. This is the first of many Arabic Zijas based on the Indian astronomical methods known as the Sinhin. The word Sinhin is a corruption of the Sanskrit Sindanta. The word contains table for the movement of the sun, the moon, and the 5 planets known at the time. This work marked the turning point in Islamic astronomy. The work contains tables for the movement of the sun, the moon, and the 5 planets known at the time. This work marked the turning point in Islamic astronomy. Hitherto, Muslim astronomers had adopted a primarily research approach to the field, translating words of others and learning already discovered knowledge. Thirdly, trigonometry. Al-Khawarizmi Zij al-Sinhin also contain tables for the trigonometric functions of sin and cosine. A related treatise on spherical trigonometry is also attributed to him. Al-Khawarizmi produced accurate sin and cosine tables and the first table of tangents. Finally, about geography. Book of the Description of the Earth, also the work known as his Geography, which was finished in 833. It is a major reworking of Ptolemy's 2nd century geography, consisting of a list of 2,402 coordinates of cities and other geographical features following a general introduction. There is only one surviving copy of Kitab Surat al-Ardu, which is kept at the Strasbourg University Library. The book opens with the list of latitudes and longitudes in order of weather zones, that is to say in blocks of latitudes, and in each weather zone by order of longitude. As Paul Gallus points out, this excellent system allows the deduction of many latitudes and longitudes where the only extant document is in such bad condition as to make it practically illegible. Neither the Arabic copy nor the Latin translation include the map of the world itself. However, Hubert Downich was able to reconstruct the missing map from the list of coordinates. Downich read the latitudes and longitudes of the coastal points in the manuscript or deduces them from the context where they were not legible. He transferred the points onto graph paper and connected them with straight lines, obtaining an approximation of the coastline as it was on the original map. He then does the same for the rivers and towns. Al-Khawarizmi corrected Ptolemy's gross overestimate for the length of the Mediterranean Sea from the Canary Islands to the eastern shores of the Mediterranean. Ptolemy overestimated it at 63 degrees of longitude, while Al-Khawarizmi almost correctly estimated it at nearly 50 degrees of longitude. He also depicted the Atlantic and Indian Ocean as open bodies of water, not landlocked sea as Ptolemy had done. Al-Khawarizmi prime meridian at the Fortunate Isles was thus around 10 east of the line used by Marinus and Ptolemy. Most medieval Muslim gatherers continued to use Al-Khawarizmi prime meridian. In addition, I want to tell about the contribution of Al-Khawarizmi to Jewish calendar. Al-Khawarizmi wrote several other works, including a treatise on the Hebrew calendar titled Risalah fi Istikhraj Tarikh al-Yahud, Extraction of the Jewish Era. It describes the Metonic cycle, a 19-year intercalation cycle, the rules for determining on what day of the week, the first day of the month Tishrei shall fall, calculates the interval between the Anno Mundi or Jewish year and the Seleucid era, and gives rules for determining the mean longitude for the sun and the moon using the Hebrew calendar. Similar material is found in the works of Abu Rayhan al-Biruni and Maimonides. In the end, I think that is all from our group to present about Muslim scholar, which is Al-Khawarizmi, a father of algebra. We hope that other people can take some benefits when we learn about Muslim scholar in Islamic science. That's all from us. Thank you. Assalamualaikum warahmatullahi wabarakatuh.